Why the Atlantic Ocean current system is slowing down and its implication. A recent study notes that the Atlantic meridional overturning circulation is losing its stability. Modeling studies have shown that an AMOC shutdown would cool the northern hemisphere and decrease rainfall over Europe. If you have watched the 2004 movie The Day After Tomorrow, you might remember that a disruption in the North Atlantic Ocean circulation made the planet enter another ice age. A study published last week in Nature Climate Change notes that this circulation, known officially as the Atlantic Meridional Overturning Circulation AMOC, is losing its stability. According to IPCC's report AR6 released on August 9, it is very likely that AMOC will decline over the 21st century. The author of the paper, Nicholas Boers, explains in a release, the findings support the assessment that the AMOC decline is not just a fluctuation or a linear response to increasing temperatures but likely means the approaching of a critical threshold beyond which the circulation system could collapse. What is AMOC? The AMOC is a large system of ocean currents. It is the Atlantic branch of the ocean conveyor belt or thermohaline circulation THC and distributes heat and nutrients throughout the world's ocean basins. AMOC carries warm surface waters from the tropics towards the northern hemisphere, where it cools and sinks. It then returns to the tropics and then to the South Atlantic as the bottom current. From there, it distributed to all ocean basins via the Antarctic circumpolar current. What happens if AMOC collapses? Gulf Stream, a part of the AMOC, is a warm current responsible for mild climate at the eastern coast of North America as well as Europe. Without a proper AMOC and Gulf Stream, Europe will be very cold. Modeling studies have shown that an AMOC shutdown would cool the northern hemisphere and decrease rainfall over Europe. It can also have an effect on the El Nino. A 2016 paper in Science Advanced noted AMOC collapse brings about large markedly different climate response, a prominent cooling over the northern North Atlantic and neighboring areas, sea ice increase over the Greenland, Iceland, Norwegian seas, and to the south of Greenland and a significant southward rain belt migration over the tropical Atlantic. The study team suspected that the previous model overestimated the AMOC's stability as they did not look at freshwater influence. Freshwater from melting Greenland ice sheets and the Arctic region can make circulation weaker as it is not as dense as salt water and doesn't sink to the bottom. Has the AMOC weakened before? AMOC and the THC strength has always been fluctuating. Mainly if you look at the late Pleistocene time period last 1 million years. The extreme glacial stages have seen weaker circulations and slowdown in AMOC, while the glacial terminations have shown a stronger AMOC and circulation, explains Nirmal B., a PhD scholar from Geoscience Research Lab VIT Chennai who has been studying Atlantic paleoclimate. We know about the past fluctuations of studying paleoclimatic proxies such as the sea surface temperatures, salinity, and isotope signatures from single-celled organisms called foraminifera. But the changes we experience in the last 100 to 200 years are anthropogenic, and these abrupt changes are destabilizing the AMOC, which could collapse the system. In February, researchers noted that AMOC is at its weakest in over a millennium. The team studied the evolution of AMOC over the past 1600 years. Stefan Rasmussen, one of the authors of the study published in Nature Geoscience, explained in a release the study results suggest that AMOC has been relatively stable until the late 19th century. With the end of the Little Ice Age in about 1850, the ocean currents began to decline, with a second more drastic decline following since the mid 20th century. Why is the AMOC slowing down? Climate models have long predicted that global warming can cause a weakening of the major ocean systems of the world. Last month, researchers noted that a part of the Arctic's ice called Last Ice Area has also melted. The fresh water from the melting ice reduces the salinity and density of the water. Now, the water is unable to sink as it is used to and weakens the AMOC flow. A 2019 study suggested that the Indian Ocean may also be helping the slowing down of AMOC. The researchers said as the Indian Ocean warms faster and faster, it generates additional precipitation. With so much precipitation in the Indian Ocean, there will be less precipitation in the Atlantic Ocean, leading to higher salinity in the waters of the tropical portion of the Atlantic. These saltier waters in the Atlantic as it comes north via AMOC will get cold much quicker than usual and sink faster. This would act as a jump start for AMOC, intensifying the circulation, author Alex Fedorov said in a release. On the other hand, we don't know how long this enhanced Indian Ocean warming will continue. If other tropical oceans warming, especially the Pacific, catches up with the Indian Ocean, the advantage for AMOC will stop. If we continue to drive global warming, the Gulf Stream system will weaken further by 34 to 45% by 2100, according to the latest generation of climate change models, notes Ramspot. This could bring us dangerously close to the tipping point at which the flow becomes unstable. Nicholas Boers added, we urgently need to reconcile our models with the presented observational evidence to assess how far or how close the AMOC really is to its critical threshold. Thank you.